kinetic energy at 2 meters should be equal to the initial one plus the work done by this force during this 2 meters, right? This one will be 1/2 m velocity at the end square. This one is 1/2 m velocity at the beginning. And the work is 0 to 2 fx dx, because you need the area here.
Can we just take the integral of 2x, so it'll be 2x squared over 2? So it'll be x squared?
X squared, yeah. So when you calculate, here is x squared, 0 to 2. So you just need, if you calculate, it's 4.
That'll be the work.
Yeah, you know how either way it's fine.
Okay.
You understand here, right?
Yeah.
It's just calculate the area.
Right.
So that's the only thing. You can even put, there is 2, here is 4, you know, it's 2 and 4, it's calculate times 4, that is also 4.
Right.
But sometimes they will give you maybe 2x squared or something. You can only use this to calculate, right? So 1/2 we know is 2 kilograms times 2 times the velocity square times 2 times 9, because its initial was 3, plus 4. So the velocity is equal to 9 plus 4, which is 13. Square root 13, if you calculate it's around 3.6. So this question is B. Okay. Number 18, the only force acting on 1.8 body moves along x, fx equal to negative 3x Newton. The initial velocity is 8 meters per second. So at what value of x will the body have a velocity of 4 meters per second? So you need to calculate this x. It's the same thing as the previous question, right? So the kinetic energy at the beginning is, right, here, which is times 1.8 times 8 squared, and it's 57.6, the initial kinetic energy. And here, in the end, the kinetic energy is, because we know the velocity is 4, it's 14.4. So we know how much work the force did. because it's the change of kinetic energy. You just use 14.4 minus this 57.6, and it will be negative 43.2. That's how much work this force did from 0 to x, right? And the work will be Fx from 0 to x. We don't know which x is this, times dx. And which is x squared from 0 to x. But we know that is right? So it is 3 over 2 x squared equal to, if you calculate x is 5.4 meter. 5.367 meter. And it will be B. You understand every step?
Up until you got down here, I understand you took the integral because that will give you the force, and the
That
negative.
will give you the work done by the force, right? From 0 to x.
Right. And it's equals to the what? The work.
The work we calculate here. Right?
So you brought that negative 3/2 over,
Mm-hmm.
and then you took the square root.
Square, yeah, it will be, right? And then you take the square root.
Okay.
Just use a calculator. Look at this number.
It's not that these problems hard, but every question is adding something different. They're
Yeah, but
adding
the
different
basic
things.
the
Basic
basic
stuff
thing
is-
is the energy conservation of the energy, right?
Okay.
If you this equation, if you get it right, the rest is calculation.